Okay, with the start of today, this is your last lesson for geometry. You have made it. It's the last lesson, very little new material. This is it, boys and girls. We're almost done with geometry. So without further ado, let's get this last lesson started. The quicker we get started, the quicker you are done. Except for your review and final, but material-wise, we've got it made. So today we are looking at kind of putting permutations and combinations into one nice, neat little package. We're putting everything together into one where you have to read the problem and decide, is it asking for a permutation? Is it asking for a combination? Which one are we doing? That's the goal for today. Then we'll get into a little bit of geometric probability to kind of round out the unit. So let's recall our definitions. A permutation is an arrangement of objects in which order matters. So if you got selected for president, that would be different than you being selected for vice president. Order matters. A permutation of n objects taken r at a time is denoted by NPR, where that's equal to n factorial over n minus r factorial. On the calculator, remember, you can do this by going to Menu, Probability, Permutation. If the numbers line up still on your version of the Inspire, that's Menu 5-2. That's how you can do this on the calculator. And remember, it'll come up like this. You'll just have a set of parentheses. That's all the calculator will put up. You'll have to put in your n, comma, and then your r. So n goes in this first blank, r goes in the second blank. A combination is an arrangement of objects in which order does not matter. So you're being picked for a committee, or you're being picked to go on a trip. It doesn't matter the order you're picked in, as long as you're picked, you're happy. That's a combination. Our formula for that starts off just like a permutation. N factorial over n minus r factorial. However, we have to also divide by r factorial to get all those repeats out. The repeated groups need to go away. They need to disappear. So that's why we divide by r factorial. So again, this is the same as a permutation divided by r factorial. And to do this one on the calculator, so this, I guess I should do that. To do this one on the calculator, it's the same thing. Menu, probability, except this time we'll say combination, or Menu 5-3. This will bring this up on the calculator. Again, just like permutation, n goes in the first blank, R goes in the second blank. So that's just kind of a quick, like, definition-based review of permutations and combinations. Let's look at an example-based review. So let's suppose a bag has 3 distinct colored marbles. We've got red, green, and purple. We wish to draw 2 marbles at random without replacement. So we're going to draw one, put it to the side, and draw another. How many different arrangements are possible if the first case is order matters? Since order matters, this is automatically a permutation. Order matters. So if you choose red first and then green, that's different than green than red. So these are different. Well, let's think about it. Let's use our calculator to help us here. So our N is how many marbles we have. N is 3. Our R is how many we're picking. We want to draw out 2. So R is 2. And we're doing a permutation. So we'll say NPR 3, 2. And see what that gets us. And let's remember how to do this on the calculator. We go to menu, probability, permutation. And then we'll say 3, 2. Boom. Tells us there are 6 ways to do this. Okay, fair enough. So how many different arrangements? There are 6 arrangements. If order matters, there's 6 different arrangements. Now, let's say order does not matter. If order does not matter, this is a combination. So first we had permutation, then we had combination. So kind of going along with the red and green, if I drew a red, then a green, or a green and then a red, a combination says that these are the same. Those are the same. It doesn't matter the order I drew them. I drew them, move on. That's all that matters. So again, we've got 3 marbles to draw from. We're drawing 2 of them. So if we use our calculator to do combination, NCR 3, 2. Let's see what that'll get us. So we're going to go to menu, combination, or sorry, menu, probability. So 5, combination is 3. Menu 5, 3. We have to do 3, 2 in the parentheses. Now it tells us there's 3 arrangements. That's our answer here. There's 3 arrangements. So if order matters, there's more than if order does not matter. So to recap, to use permutation, you will draw without replacement, and order has to matter. let me capitalize this P. Okay, so to use permutation, you draw without replacement and order matters. To use combination, you still have to draw without replacement, but order does not matter. That's the difference in the two. Permutation, order matters. Combination, order does not matter. So let's look at this next example. Now, suppose you have a bag of 2 red, 3 green, and 4 purple marbles. And all this note is saying is that if you have 2 red, you can't say, oh, this is red number 1 and red number 2 and tell them apart. No, they're red. You can't say this one is Bob, this one's Susie. You mix them up, they're just going to look red. So 2 red, 3 green, 4 purple. We're going to pick all 9 marbles out of the bag. So what this tells us is that n is equal to 9. How many different arrangements are possible? Well, since I have 2 red that look exactly the same, I have 3 green that look exactly the same, and then 4 purple that look exactly the same. These are repeats. So this is where we have, this is like the Mississippi problem, where we have to deal with having repeats. So I'm going to have 2 red. I'm going to have 3 green. And I'm going to have 4 purple. That are all repeats. So to find how many different arrangements, I'm going to do 9 factorial. And then I'm going to have to divide by my repeats. So 2 factorial times 3 factorial times 4 factorial. Now let's put all this in the calculator. So I'm going to do 9. To get the factorial, you can say menu 5, 1. Menu 5 for probability, 1 for factorial. So 9 factorial divided by. I need to make sure I put a parentheses here so it captures my whole denominator. And I'll do 2 factorial. Menu 5, 1. And 3 factorial. And 4 factorial. So, enter. Notice this looks exactly like what's on my paper. This is one way to check if you entered it in the calculator right. If what you put in looks exactly like what's on your paper, you did it right. If it doesn't look like this, you did something wrong and the answer is wrong. Okay, so we did it right because they match. So that means our answer is 1,260. So there's 1,260 arrangements. I could say different arrangements. I'm just going to leave it short and say arrangements. 1,260 arrangements. That's how many different ones there are. Okay, on to the back. Student council members have selected 12 students to choose from to fill the positions of president, vice president, secretary, and treasurer. Each student can only fill one position. How many different outcomes are possible? Okay, so let's see. We're dealing with president, vice president, secretary, and treasurer. So right there, what does that tell you? This tells us that order matters. If you get picked for president, that's different than getting picked for vice president. Order matters. And then it says each student can only fill one position. So we draw without replacement. So I'm just going to say without replacement. So if order matters and we do it without replacement, this becomes a permutation. Okay, well, we know what it is. So let's see, how many are we picking from? What's our N? N would be 12. What's our R? How many are we picking? Well, I see 1 position, 2, 3, let's see, 4 positions we're picking. So R is 4. It's a permutation, so we can do this in the calculator now. NPR 12, 4. Do that in the calculator. So go back down here. Menu 5, 2. We're going to say 12, 4. 11,880 different outcomes. That's how many you could have. 11,880 different outcomes. Now let's switch gears. Now they're still picking from 12 students, but this time we're just doing a 4-person committee. And again, each student can only fill 1 position. So now, order does not matter. It's a committee. Who cares the order they get picked? And since we can only fill 1 position, this is without replacement. So what does this become then? Order does not matter, and we do it without replacement. This is a combination. So our N is still 12. We got 12 to pick from. We're filling a 4-person committee. So that means R is 4. And we said it's a combination. So NCR 12, 4. So let me move this over here. So menu 5, 3 for combination. We want to do 12, 4. 495 is what we're left with. So we're going to have 495 outcomes. If it's just the committee, there's 495 outcomes. If order mattered, meaning we were naming officers, then it'd be over 11,000, almost 12,000. Okay, there's those two. Now let's look at the next example. So Brett is taking a 5-question multiple choice geometry quiz. Each question has 3 possible answer choices: A, B, or C. How many ways can he answer this quiz? Well, let's think about this. There's 5 questions, right? So for number 1, how many answers can he pick from? 3. Okay, number 2, how many answers can he pick from? A, B, or C. There's 3 there. Number 3, how many can he pick from? 3. And we can keep going until we get to question number 5. There's only 5 questions on the quiz. Each time he can pick 3 answers: A, B, or C. Well, to figure out how many ways, you just multiply. This is the same as saying 3 to the 5th power. Notice this is the number of answer choices raised to the number of questions. 3 to the 5th power, which, let's see what that gives us in the calculator. 3 to the 5th, 243. So how many ways? There's 243 ways he can answer this quiz. Now, what's the probability he makes a perfect score? So let's think about a paper for a second. How many ways can you make a 100? So a perfect score means he makes a 100. There's only one way, right? You get all the right answers. So that means the probability that he makes 100 is 1 out of 243 ways, which as a decimal, 1 divided by 243, that's 0.004115. Let's just write the whole thing. So 0.004115, which as a percent, and you don't have to put this, but you can, 4.4115%. This is the main one I'm looking for right here. And that's the probability he makes 100. If he just guesses randomly, he didn't study, boom. That's the probability he makes 100. Then they flip it on us. What's the probability he makes a 0? Well, making a 0 means he answers nothing correctly. Answers nothing correctly. This one takes a little bit of thought. So if it's multiple choice, there's only one right answer per question. So let's say for number 1, the answer is A. How many wrong answers are there? 2 wrong answers. For number 2, how many wrong answers are there? 2 wrong answers. And this keeps going all the way until you get to number 5, the last question. There's 2 wrong answers there too. So 2 to the 5th, let's see, 2 to the 5th, no, delete. That's 32 ways to get all wrong answers. $32 ways to get all wrong answers. Okay, well, that's just how many ways there are to make a 0. They want the probability he makes a 0. So the probability would be 32 over 243. Let's see what that gives us. 32 divided by 243. Okay, let's try this. Control Enter. There we go. As a decimal, that is 0.131687. 0.131687. So that's the probability. As a percent, that's approximately 13.17%. So he's got a slim chance to make 100, but pretty good chance he's going to make a 0 if he guesses all random. So on a little bit of a side note, that's the reason that it's actually better. Let's say you knew nothing and you were going to guess everything. Don't just go willy-nilly guessing, oh, A, C, D, B, A. If you go all willy-nilly and you just guess all over the place, look how high your chance is of making a 0 with only 3 answer choices. That's a pretty high chance. You need to pick a letter and guess that letter on every one of them. So if you're guessing randomly and you're like, I don't care, A, because theoretically you can make a 33 doing that. So yeah, don't just sit there and guess all random answers. Pick a letter and guess that letter every time. You'll make a higher grade, guaranteed. Okay. So there's that one. Now on to the next set. Now we start talking about geometric probability. So before we do that though, let's say theoretical probability. Wait, back up, not theoretical probability. Not theoretical probability. Okay, so now here, if we think back to the day 1 of the unit, we learned that sample space is the set of all possible outcomes in an experiment. Sample space is the set of all possible outcomes in an experiment. If every one of the outcomes is equally likely, then the theoretical probability is the number of favorable outcomes divided by the sample space. Let me say it this way, divided by the number of outcomes in the sample space. Number of total outcomes. In sample space. No, what's there? So the number of favorable outcomes divided by the number of total outcomes in the sample space. Or another way you could say this is part divided by whole. It's another way you could put it. So this is talking about geometric probability now. Let's look at this first example. Let's say a point is chosen randomly on the segment AD. So here's our segment. If I went all the way from A to D, what would this equal? Well, 4 plus 3 plus 5 gives us 12. So this whole thing is equal to 12. Okay, find the probability of each event. A asks us to find the probability that the point is on AC. Well, I go from A to C. So that's 4 plus 3. So I'm going to say probability equals 4 plus 3 over 12, which is 7 over 12. That's your probability, 7 over 12. See what we did there? The part we want is 4 and 3 over the whole thing, 12. Okay, B says we want the probability the point is not on AB. So I do not want AB. Well, that probability, I don't want AB, so I'm just left with 3 plus 5 over 12, which is 8 over 12. I need to always try to reduce this. This reduces to 2/3. There's that probability. You can put it as a decimal like we have up here, or you can leave it as a fraction. The choice is yours, but you need to be prepared on the test for it to look either way. Decimal, fraction, percent, however, just be prepared to go between those. For instance, 2/3 as a decimal is 0.67. As a percent, it's 67%. So you need to be able to go all three ways if they ask you to. Okay, that's doing the line segments. Hopefully you found that pretty easy peasy. The spinner. So now, if you've ever played a game, like the game of life, I can't remember any of the other games, but there are several games that use spinners. That's all based on probability. So in a circle, there's how many degrees? 360. A whole spinner is 360 degrees. So A asks us to find the probability that the pointer lands on red. Well, that probability, we want red. Red over here is 80 degrees. So 80 over 360. But remember, we need to reduce it. So let's see if our calculator can help us there. 80 divided by 360. It's going to be 2/9. So this is 2/9. That's our fraction. Again, you can leave it like that, but just know how to get the decimal. So that's 0.222 repeating. So you could say 0.22, or that's also 22%. You need to know how to get all three ways. You don't have to give me all three, but you need to know how to get all three. Okay, so there's that one. The next one, find the probability that the pointer lands on purple or blue. Purple or blue. Well, let's see. Here's purple, it's 75. Here's blue, that's 60. So probability is equal to 75 plus 60 divided by 360. Let's see, 75 plus 60 is 135 over 360, which reduces 135 divided by 360. That reduces to 3/8. So 3/8. Now, again, as a decimal, this is 0.375, which is 37.5%, going all three ways. Okay, and the last one. The probability of not landing on yellow. So I don't want yellow. I want everything else but yellow. So we can say that's probability is 80 plus 45 plus 60 plus 75. I just add up everything but the yellow over 360. Okay, that's going to give me, let's see, what was my yellow? 100, okay. It's going to give me 260 over 360, which, what's that reduce to? 260 divided by 360. 13 over 18. So 13 over 18 is my fraction. If I put that as a decimal, it's going to be 0.72, which is 72%. Okay, so there's the notes. They were a little bit long today, but we covered a lot of ground. So, like I said, there's the notes. This is the last day of the unit, so we finished our last day of notes. Stay tuned for the guided practice.